Hello young researchers, in this video we are going to tell you about our research in the Indonesia Science Project Olympiad 2022. Assalamualaikum warahmatullahi wabarakatuh.
Sleeper orchid is one of the endemic and rare orchid in East Java, Indonesia. According to Rohim, this is due to disturbances from natural disasters and direct harvesting in their natural habitat. Meanwhile, in artificial habitats, proper selection is needed so that sleeper orchid doesn't die easily.
Generally, people still use chemical fertilizers in orchid cultivation. Even though chemical fertilizers can cause environmental pollution and are not suitable for the sleeper orchid because orchid leaves are very sensitive to chemicals. Even incorrect fertilization can cause orchid leaves wither and die.
Therefore, to overcome these problems, we conducted research entitled EcoLeaf, Eco-Friendly Slow-Release Hydrogel Fertilizer for Organic Waste with Encapsulation Technology to accelerate vegetative phase in sleeper orchids. I am Muhammad Izzat Adnan Kamal and my friend Antaressa Putra Prihandoko. We are from MTSN 1 Malang City.
The objective of this research consists of, first, to find out the potential of organic waste from orange peel, banana weevil, and aking rice as raw materials for making slow-release fertilizer through an in silico and effectiveness test.
Second, to determine the effect of organic liquid fertilizer and aking rice starch concentration on the characteristic and effectiveness of EcoLeaf. And the last is to find out the best formulation of the EcoLeaf sample.
We conduct this research in the science laboratory of MTSN 1 Malang City and the researcher's house from October 2021 to February 2022 with strict health protocols.
Our research uses an experimental method with an in silico quantitative and qualitative approach. This uses two factors consisting of the aking rice starch and organic liquid fertilizer concentration with 3 repetitions for each sample to get valid data. There are the tools and materials that we use in this study.
The making process of EcoLeaf consists of several stages. First, the preparation of tools and materials, followed by the making starch powder, and then making organic liquid fertilizers from orange peel and banana weevil using the fermentation method.
Furthermore, the making of EcoLeaf samples using mycorrhizal fertilizers encapsulated with aking rice starch and organic liquid fertilizer based on concentration that have been set before, with addition alginate as a semi-permeable coating matrix.
And there were the result of our research. Based on the prediction result using computational simulation, the most potential of active compound as an antibacterial and antifungal agent showed that tannin is the most potential because it has the strongest interaction in inactivating bacterial proteins based on binding affinity, RMSD, and hydrogen bond values. There is 2D and 3D visualization of the predicted interaction using computational simulation.
Toxicity prediction result show that active compounds is organic liquid fertilizer and non-toxic compounds and are categorized in class 5.
Based on the phytochemical screening test result of organic liquid fertilizer, several active compounds were detected such as tannins, flavonoids, phenols, and triterpenoids that have the potential to become antibacterial and antifungal compounds.
Furthermore, the result of testing the characteristic of the EcoLeaf on the dimension parameter show the base sample is S3F2 with a different value of the 0.003 mm. Based on the weight uniformity test result, the base sample is the S2F1, S2F2, and S2F3 samples because have a lowest deviation standard values. Based on the water content test result, the base sample with the highest value is S1F3 sample by 18.5%.
The water absorption test result shows the base sample with the highest average value is the S3F3 sample with a value of about 40%. Based on the biodegradation test result, the base sample is the S3F3 sample by 16.5%.
Furthermore, in the effectiveness of the EcoLeaf test result on the growth of sleeper orchids, the base sample is the S3F3 sample, then can help accelerate increase leaf length 2 times better and leaf width of 3 times better than the control samples. This is because the higher concentrations of organic liquid fertilizers and starch are used the more optimum nutrients are given, so that can help accelerate the growth of sleeper orchid plants.
Based on the overall test result, it can be concluded that eco-leaf sample with the best characteristic is the S3F3 sample. And in the germination test result of the S3F3 sample, it was found that the mycelium of mycorrhizal fungi can grow quickly within 2 days.
From the comparison table, eco-leaf is better than the 8 previous innovation. In addition, the advantages of this innovation consist of utilizing organic wastes that have not been used optimally, cheap and easy to find.
The eco-leaf contains NPK nutrient which is following Indonesian standards, and hormones such as cytogenin and gibberellin which can support plant growth.
And also use an encapsulation technology that can make eco-leaf more effective, efficient with a simple design, environmentally friendly, and economical with affordable price.
The conclusion of this research include: first, organic fertilizer and acking rice waste has great potential as a raw material for slow-release fertilizer based on the characterization test and its potential as an antibacterial and antifungal based on in silico test.
Second, the concentration of organic liquid fertilizer and acking rice starch affect the characteristic and effectiveness of the eco-leaf samples. And the last, the S3F3 sample is the best sample and the most effective for helping the growth of sleeper orchid as a substitute for chemical fertilizers. So, this is the last of our presentation. The following are our documentation and references. Thank you so much for your kind attention, and we are sorry for our mistake. Wassalamualaikum warahmatullahi wabarakatuh.